So we will now go for another application of Gauss law to find the electric field due to a uniformly charged thin spherical shell as it is mentioned above. So we'll start with let from the figure number A from figure number figure number 1A 1A let let sigma be the surface charge density surface charge density of the sphere of a radius capital R. Okay, so let there are the situations that you can find the electric field at the point. We have three cases three cases to find the electric field due to spherical shell. Okay, so for case number one, then observation point observation point lies outside the shell outside the shell. Okay, so here we choose a point P at a distance where R from the center of the sphere. Okay, center of the sphere, and then draw a Gaussian surface around it, you know around it. So this spherical shell has spherical symmetry. This spherical shell has spherical symmetry. Okay, so this means the electric field in a certain radius small r will be same throughout the shell, around the shell. So using Gauss law अब आप करिए Gauss law, in accordance to Gauss law, so this d phi is equal to surface integral of E dot ds is equal to net charge enclosed by the surface divided by epsilon 0. This is equation number 1. Okay, so before integration you have to remove the vectors using a vector dot b vector is equal to magnitude of a and magnitude of b vectors and cosine of angle between the two. Okay, so using this we have E dot ds is equal to E ds, okay, and cos of 0 degree, because as E and ds both are in the same direction. So I see in the diagram electric field is pointing out in this direction, and if you will choose small part of the Gaussian surface like ds over here, so this surface area will also have the same direction. So the angle between the two is equal to 0. So you are reduced with uh, e, this is the integral we reduce by this, d phi is equal to uh, e ds only. It is equal to q net charge enclosed by the surface and epsilon 0. So here, if you have to find the net charge, so you use the surface charge density. So surface charge density is denoted by sigma, that is the net charge upon the surface on which the charge exists. So this is the surface having the certain radius r. So you will write it 4 pi capital R square. You can use this part over there. Okay. So if you have to find just electric field, so you need not to worry about this part. So I will write it like this. You can take, as the electric field is uniform, you can take electric field outside from this, and you are reduced with ds, that is equal to q upon epsilon 0 using net charge is equal to q. So E into if you will add small surfaces, you will reduce, you will left with 4 pi, total Gaussian surface is pi r square. So this is q by epsilon 0, and then electric field is equal to q upon 4 pi epsilon 0 r square. As electric field is a vector quantity, so I will write it like this: electric field as a vector quantity, and then it is equal to q upon 4 pi epsilon 0 r square in the direction of r. So it is equation number 3. So this is what the electric field outside the spherical shell if the observation point lies outside the shell at point P. So as it is shown in the figure number 1a. So another case, the case number 2. So I would like to make few remarks over this. One thing, this a few important point that could be drawn from equation number 1. Electric field number 1. Few conclusion from this. Conclusions. Okay. So first conclusion is the electric field is directed outward. The electric field is directed, okay, outward if q is greater than 0, and inward if q is less than 0. Okay. So however, this is the situation, and this exactly behave as the charge q is placed at the center. Charge q is placed at the center. This is very important when you will solve the numerical problem. You must know it. Placed at the center. This conclusion is very important. Okay. So now another point is second case. Case number 2. Okay. Then the observation point when the observation point lies on the shell, on the shell. Okay, so in this case what will happen? R is replaced by the radius of the shell. Okay, so using equation number 3, using in equation 3 we have, so it will become E vector is equal to Q upon 4 pi epsilon 0 is a capital R square in the direction of R. This is equation number 4. And now the case 3, then observation point lies inside the shell, inside the shell. Okay, so as there is no charge inside the shell, charge resides only on the surface of the shell. As charge reside only on the surface, only on the surface, so Q net is equal to Q that is equal to 0 inside the shell. So electric field inside the shell, inside the shell, so electric field inside the shell is 0. With this I will end up this article. Thank you very much.